Hello, welcome back. So we're still busy with these measures of central tendency, and we're now on to the harmonic mean. So let's get going. So what is this? This is a type of weighted mean where an observation's weight is inversely proportional to its magnitude. So it looks like this. It looks rather strange at first. So the harmonic mean, what we have in the numerator is the number of observations. And then in the denominator, we sum up over here. Remember sigma there, sum up. We sum up the reciprocal of all of the observations. So let's try this example and it'll clear everything up. So we have here these observations. There's 1, 2, 3, 4, 5 of them. So to work out the harmonic mean, we've got 5 in the numerator because that's the number of observations. Then in the denominator, we sum up the reciprocals of all of these observations. So we take 1 over 1 and we add 1 over 2, and we add 1 over 3, and add 1 over 4, and add 1 over 500. So if we work it out, we'll see that the harmonic mean comes to 2.39. Now, if we compare that to the arithmetic mean, we see the arithmetic mean is much, much higher because we've got this one outlier over here, which is causing the arithmetic mean to shoot up. So what we can say is that this outlier, it's got much less influence with the harmonic mean. So the harmonic mean, therefore, it's useful as a measure of central tendency if we've got these outliers. That's what we can conclude. And the harmonic mean, it's used most often when the data consists of rates and ratios, like with the PE ratio. Remember, in a few classes ago, we discussed what the PE ratio is, and we did say we were going to do it in a lot of detail when we get to the equity section. But just to revise quickly, let's just have just for a bit of fun. PE is like this. It's the share price divided by the earnings per share. So let's say a company's got a share price of $10 and the earnings per share is 1. So this means that the PE ratio is going to be 10 times. So I'm just going to make that there, 10 times. Right. So this means that the share price is 10 times higher than the earnings per share. So what we say is that the share is trading at a multiple of 10 times its earnings. So that's enough for now, and we'll do that in more detail as promised when we get to the equity section. But let's try this example over here. So we've got 3 companies, and these are their respective PE ratios. So if we work out the arithmetic mean, we see it's 11.67. But if we do the harmonic mean, we see that it comes out at 9.44. So we see that the harmonic mean, it's not so affected by this big one here, by this big PE ratio of 20. So in other words, the harmonic mean, it's giving less weight to that high PE there of 20. Great. And one useful thing about the harmonic mean is that we use it to calculate the average cost of investments purchased over time. And this is when the investor purchases the same amount, and that's the important part. When the investor purchases the same amount of the asset with each purchase, we call it dollar cost averaging in the US or rand cost averaging in South Africa. So it's the same formula as before, but our N is now just the number of purchases that the investor makes. And remember, the purchases, they must be of the same amount. And now our X over our observation in each case is going to be the price paid for each purpose. So again, we sum up over here the reciprocal of each price paid for a bigger part of the reciprocal of the price paid for each purpose. So let's try the example. That'll help a lot. So at the end of the last 3 months, Kevin purchased $500 of the equity growth mutual fund shares of Best Investments. So he's investing into Best Investments equity growth mutual fund. And the important part here is he's putting in $500 each and every month. So we've got the same amount. So we must use the harmonic mean. So these are the prices that he paid. So what is the average cost per share? So he's done 3 purchases there, so that's our numerator. And then in the denominator, we take the reciprocal of each purchase price. So it's 1 over $2.10, and we add 1 over $2.30, and we add 1 over $2.40. So it comes out at $2.25. So if we work out the arithmetic mean, we see there it comes out at 2.26. So we see again that the arithmetic mean is highest. The arithmetic mean is always the highest, and the harmonic mean is now lower. So for all values that are not equal, like here, these values were not equal, these values are different, then the harmonic mean is always the smallest. And we've discussed this already, that the geometric mean is less than arithmetic. So now we can see what the order is. And remember, the exam, it's quite conceptual, and they love these kind of conceptual things. So I thought we must put that in over there. Great. So now that we've discussed these different measures of central tendency, now we're going to look at deciding which measure to use. So first we must collect our sample. And now if we include all the values, including our outliers, then we must use the arithmetic mean. If we are doing compounding, then remember from the previous class, we must use the geometric mean. And if we've got extreme outliers, we should use the harmonic mean that we've just looked at, or we could do the trimmed mean or the Windsorized mean, and those two we did in the previous class. And I got this from CFA Institute, so I'm just putting the disclosure in over there. And I don't think this last point is very important at all, because there's no calculations needed for this, but it's just an interesting fact that the arithmetic, the geometric, and the harmonic means, they are mathematically related to one another. So if we take the arithmetic mean and multiply it by the harmonic mean, it's the same as the geometric mean squared. We don't have to go to all the detail of that. It's just a mathematical fact. Great. So this is now the last thing we need to look at in this section. In this class is the quantiles, but it will take a bit of time because it's quite an involved process. So let's have a look. So what are these quantiles? So a quantile is also known as a fractile. It's a value at or below, and that's the important part, is a value at or below which a stated proportion of the data lies. So we need to, first of all, get our English right. So a median, this is the one we've done in the previous class. As we know, it divides a distribution in half. With a quartile, this divides a distribution into quarters. And a quintile, we divide into fifths, and a decile into tenths, and percentile into hundredths. So let's try a few examples that will clear all of this up. If they ask us, what is the third quartile? So quartile, we're dividing into quarters. So third quartile will be 3 times 25. So let's just do it like that. 3 times 25 quarters there. So 3 times 25, third quartile, that's going to be 75% of the observation in the distribution will fall below the third quartile. So the third quartile, what we can say, that is the 75th percentile. Let's try another one. What about the 6th decile? Well, deciles into tenths, like we know. So 6 times 10 is 60%. So 60% of the observations are going to fall below the 6th decile. So the 6th decile is the 60th percentile. Then what about the 50th percentile? Well, if it's in percentiles, then it's easy. Then they've done the work for us. Then this just means 50% of the observations in the distribution, they're going to be below the 50th percentile. And as we know, like we've discussed over there and in the previous class, the 50th percentile, that in actual fact is the median. Great. Now, this point over here, I don't want us to stress too much about this last point, because what I've done over here, I've copied and pasted onto the next slide into our example, which is going to clear everything up. But let's look at it quickly. The position of the observation at a given percentile, which we call y, with however many data points, sorted in ascending order is. So what do? We take the number of observations, then we add 1, and we multiply it by whatever the percentile is. And that gives us the position of the observation at a given percentile. So without any further ado, let's do the example, and this will help us tremendously. So they're asking us here, what is the third quartile for the following distribution of returns? So what I've done is I was kind to us. I arranged this distribution of returns in ascending order from smallest to largest. So this is the part that we said is copied and pasted from the previous slide. The position of the observation at a given percentile, which is y, with however many data points, sorted in ascending order. So we have to be in ascending order to get the position of the observation. So first of all, we need to see what is our n here. How many observations are there? Well, let's count them. There's 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there are 8 observations in the data set. So therefore, the position of the third quartile, how can we do this? So there's 8 where, as a big point, the third quartile can be identified as. So where is the third quartile? What position is it? Well, we take the number of observations 8, we add 1. So the third quartile, so that's going to be 3 there times 25, not so. Quartiles is into quarters. So it's going to be 3 times 25 there, which is 75. So the third quartile is going to be the 75th percentile. The third quartile is going to be the 75th percentile. So what we can then see is that the position of the third quartile is position number 6.75. So this means that when the data is in ascending order like we've done, the third quartile we've worked out, it's the 75th percentile. It's going to be the 6th data point from the left, which is 13%. But let's double check that. Let's double check that this 13% is the 6th data point from the left. Number 1, number 2, number 3, number 4, number 5, number 6. There we go. That's the 6th data point there from the left. But it's not exactly position number 6. It's position number 6.75. So we got to take there the 0.75. We got to add on 0.75 times the distance between the 6th and the 7th data point. So there's the 7th data point over there. So we've got to take our, it's going to be the 13 over there. So it's going to be the 6th data point from the left there, the 13%, plus over here, plus over there, 0.75 multiplied by the distance between the 6th data point, which is there, and the 7th data point, which is over there. So that is at there, it's 15.25%. So that is the third quartile. The third quartile is 15.25%. So what does this mean in English? So remember our quantiles, it tells us the percentage of observations below a certain number. So we can say that 75% of the observations lie below 15.25%. So let's just stop for a minute and see, how do we apply this in the investment world? Well, perhaps these could be returns of different investment funds that are investing in the same style. So we can see that to be in the top quartile, to be in the top, you need to be above 15.25%. So if you are below 15.25, then you are in the bottom 3/4, right? So that is how we could look at it in that manner. Great. And the last thing that we need to look at over here is a scenario. So I'm just trying there. You won't see it, but something was covering my example, and now it's covering me again. But it wouldn't be on your screen. I'm just trying to get rid of it. Okay, I got rid of it again. Hope it doesn't come back. Okay, so with this example here, what we've got is the net income of a sample of 100 companies. So we can see that we've got 20 bins in this scenario, and there are 5 observations in each and every bin. And we can see that the net income of these 100 companies, they start there. The lowest net income we've got is 1.25 million, and the highest is 95.37 million in this sample. So they've got a few questions for us over here, which we are going to go through together. So they're asking us the question number 1, what is the 10th percentile? Well, there's the 10th percentile over there. So there it's going to be 18.1, not so. So what the 10th percentile there, 18.1. So what does it mean in English? It means 10% of the observations lie below 18.1 million. And this corresponds to these bins here, number 1 and number 2. Now, let's try another one. What is the second quintile? So remember quintile, the distribution is split into fifths. So let's just go back here to double check. Remember, quintile divides the distribution into fifths. I just wanted us to see that again. So the second quintile then is going to be 2 times 20% is going to be 40%. So we need to go there, 40%. The answer is going to be there, not so, for the second quintile. So it's going to be 37.2 million. So what can we say in English? Is that 40% of the observations lie below 37.2 million. So the second 20% of the observations, they correspond to these bins over here, from 5 down to 8 over there. That is going to be the second 20%, the second 20% of the observations, they correspond to those bins. The first 20% would correspond to those bins over there. All right, so let's try the next one. What is the first quartile? So quartile, we divide into quarters. So it's going to be this one over here, 25%. So the first quartile is going to be there, 30.95. So here, what can we say in English? Is that 25% of the observations, they lie below 30.95 million. And this corresponds to these bins here, 1, 2, 3, 4, and 5, up to there. Right. And then what about the third quartile? We know what the third quartile is because it was the same as on the previous slide. So it's going to be quartiles 25%. Third quartile is 3 times 25%, 75%. So let's go to 75%. There is over there. So it's going to be 57.74. So what does this mean? It means that 75% of the observations lie below 57.74 million. So I just put in here, what would the third 25% of observations, they would correspond to which bins? It would be from number 11 there to number 15. That would be the third 25% of the observations would correspond to those bins over there. So the first 25% would be those from 1 to 5 there. Then the second would be from 6 to 10. And the third from 11 to 15. Right. Now we need to know this thing, what this thing called the interquartile range, and what it is the difference between the third quartile and the first quartile. So we've done those. So the third quartile we saw was 57.74, and the first quartile was 30.95. So it's just the difference between them. So that 26.79, we call the interquartile range. And then lastly, what is the median? Aha, so the median we know is the center of these 20 bins that we've got. So we're going to take the center here, number 10. So it's going to be the highest value here of the 10th bin, which is going to be 42.61. Or we could also take it, it's going to be the lowest value there of the 11th bin. So we could take one or the other, and that is going to be our median. Excellent. So we just got one more thing to look at, and then we're done with this class. And that is a box and whisker plot. So the box, this represents the lower bound of the second quartile. So the lower bound of the second quartile, it's going to be exactly the same thing as the upper bound of the first quartile. So it's the difference between that and the upper bound of the third quartile. So if we go over here, we just looked at this one over here. We used this one on the previous slide. we looked at the upper bound for the first quartile was 3.95, which is, you can just double check, it's the same as the lower bound for the second quartile. And then the top of the box is going to be the upper bound for the third quartile, which we looked at, which was the 57.74. And that interquartile range, that then the difference between the top and the bottom, that is the interquartile range, like we discussed then on the previous slide. And then what about the whiskers? So the whiskers over here are lines that run from the box up there, and then they're bound by the fences over here. So the fences are there, and these are the whiskers. So those are the fences that I'm putting into red there, and these are the whiskers. So the fences, they represent the highest and lowest value. So the highest value, if you go back to the previous slide, you see there's 95.37, and the lowest value there was 1.25. Right, and then the median, we looked at that on the previous slide. And then the arithmetic average, well, we can't work it out because we don't have all of the 100 numbers of all of the 100 companies. We don't have all of the 100 net incomes to work out the arithmetic average, but they've just given it to us, and they've said it, that they worked it out for us, very kind. It was 40.52 million. Right, and then there's just one last point, is that there is another form of this where we can take 1.5 times the interquartile range for the fences. So there's the interquartile range, 26.79. And if we take 1.5 times that, I did it quickly. We don't have to do any calculations for the exam for this, but I did it just for fun. I'm not going to write them in, but I'll just tell you what I got. So 1.5 times the interquartile range, 26.79 times 1.5, I got, it was about 40. It was about 40 million. So what we then do is that the upper fence, it's 1.5 times the interquartile range, which was 40. Let's just put it in there. So it was 40. And that is then added to the upper bound of Q3, which is 57. So if you take 57 there and you add the 40, you get 97. So it would actually include each and everything in our example, but other data wouldn't be like this. It could be that the upper bound, the upper fence could come out there, for example, and the lower fence could come out there, but ours was up there, so it did include everything anyway. But not that it's that important to do calculations. And then the lower fence, that's going to be the same thing, 1.5 times the interquartile range, which was the 40. But now we subtract that number. So we're going to subtract that number from the lower bound of the second quartile. So well, that would be then minus 40 over here. So in other words, again, it would include everything in our instance, but it might not be like that for other data. So any observations beyond the fences, those are then considered outliers. Great. So that's the end then of that class. So study hard, do all the practice problems and do as many questions as you can, and put in those hours, and we're going to be fine, and we'll see you guys in the next class. Hello, it's Tim here again. I hope you enjoyed the class and found it beneficial. We have some classes available for free on YouTube, but we have classes for the entire curriculum. The classes that are not on YouTube can be purchased from us. If you'd like to purchase the classes, please contact us for the pricing, and I've put our contact details over here. You can purchase all the classes or certain readings that you would like. When you purchase the classes, we provide you with the slides and our notes. I've assisted hundreds of candidates pass CFA exams, and I look forward to also helping you through the CFA program. I've put in 2 testimonials in the slide over here, and we also have a testimonials page on our website that you can review. I look forward to seeing you soon, and all the best.